All right, welcome to this explainer. Let's just dive right in. Today, we are strapping on our engineering hard hats to critically investigate the absolutely staggering claims coming out of Tesla's recent We Robot event. I mean, we all saw the glitz and the glamour, right? The futuristic taxis, the humanoid robots, it looked amazing. But as enthusiastic as we are about innovation, we've got to look past the dramatic lighting and the cheering crowds. We need to talk about the brutal engineering realities of these systems. We're going to examine the structural limits, the software logic, and the very real safety hurdles standing between these sleek prototypes and our actual everyday lives. Just look at the sheer unprecedented scale of the promise being made here. Elon Musk explicitly claimed that the Optimus humanoid robot represents a 10 trillion, yes, trillion with a T, dollar opportunity for household assistance. Let that number sink in for a second. We're talking about a fundamental shift in how we handle our daily lives. The idea is that these robots will be mass-produced to act as friends, assistants, and laborers right inside your living room. The ultimate promise? The total elimination of your daily chore list. It is a massive, literally world-altering hook.
But that brings us to the ultimate question we absolutely have to answer. Does the engineering actually match the hype? Throughout this explainer, we're framing our narrative as a skeptical teardown. We need to see if these beautiful Art Deco presentations can actually survive the brutal realities of structural physics, strict government regulation, and current software logic. Because let's be honest, it's pretty easy to build a prototype that looks great on a closed movie set, but it is an entirely different beast to engineer a machine that functions safely in the chaotic, unpredictable real world. Let's look at our first case study.
So, our first major area of focus is the Robovan. Is it form over function? We're assessing the high-density people mover. While most of the world's attention got captivated by the little two-seater cybercab, the larger vision actually involves this striking, completely wheelless metallic shell known as the Robovan. And this brilliantly illustrates the massive difference in engineering scope between the two. The cybercab is aimed squarely at the personal use taxi market, but the Robovan, it's designed for mass transit. We're talking about moving up to 20 passengers or heavy cargo in a single trip. The structural and logistical demands of moving 20 people safely at once are exponentially higher than moving just two. I mean, think about it. When you hide the wheels entirely inside a low-clearance metallic shell, you severely restrict suspension travel, you limit heat dissipation from the brakes, and you completely kneecap your turning radius. You're dealing with entirely different weight distributions and momentum physics. That is a massive hurdle for any mechanical engineer to overcome.
And that structural leap directly introduces our next topic, the no override safety hurdle and the regulatory nightmares it brings with it. So the absolutely crucial point here is understanding what we're actually looking at on a hardware level. The Robovan features a design with zero manual override controls. By definition, this means the vehicle completely lacks a steering wheel or foot pedals. There is literally no physical way for a human being to intervene or take over if something goes sideways. Imagine the potential issues in a dense, unpredictable urban area. If the software glitches or a sensor gets blinded in a crowded intersection, how do you protect those 20 passengers? From an engineering perspective, you'd have to build massive, redundant failsafes. We're talking secondary, isolated power systems, remote emergency braking that overrides the main AI, and independent steering actuators that can default to a safe stop. The harsh reality? Currently, this vehicle lacks those visible, redundant systems.
Now, Tesla's stated goal here is to dramatically lower the cost of travel for large groups. But moving 20 people without any manual backup controls faces massive regulatory hurdles. Hurdles that have actually stalled similar driverless van concepts from shipping for years. Regulators are understandably deeply concerned with safety, and the burden of proof required to deploy a high-capacity public transit vehicle with zero human backup, it is staggeringly high. The financial feasibility of mass transit relies entirely on actually deploying the vehicles. And until the regulatory bodies are completely convinced that these things have flawless fail-safes in dense urban areas, the Robovan kind of just remains a beautiful piece of Art Deco transit hardware stuck in a regulatory waiting room. All right, let's shift gears from transit hardware to robotic software. It's time for a forensic teardown of the humanoid robot Optimus, autonomy or puppetry. At the big reveal event, these humanoid robots were out there performing highly complex social and technical demonstrations. They were mingling in the crowd, dancing, serving drinks, even playing games like charades. It really looked like the sci-fi future had finally arrived. And frankly, who wouldn't want a robot that can mix a perfect margarita? But as analysts,
we really have to ask a Socratic question to challenge this. Who is actually driving the Optimus robot? Are we witnessing true, independent autonomy, processing these complex social interactions in real time? Or is there something else happening behind the curtain? We got to give it to you straight here. There is significant data-backed skepticism about their actual autonomy during these highly publicized demos. When we look a little closer at the footage, we start to spot the undeniable tells of teleoperation. First off, the response speeds to random questions from the crowd were just suspiciously fast for current on-device AI processing capabilities. Second, the robots exhibited incredibly natural, human-like verbal stutters and conversational mistakes. And third, different Optimus units somehow had entirely distinct voices, cadences, and personalities. This rapid-fire forensic evidence strongly points to humans pulling the strings. It looks a lot more like human operators controlling the robot's speech and actions rather than genuine on-device robotic thought. Let's clearly map out the gap here between the marketing and the reality. The claim from Tesla engineers is that the AI runs genuinely on-device, making independent decisions. But the observation from our critical teardown reveals a human-in-the-loop setup. Now look, this doesn't mean the hardware isn't impressive. It is. What it means is that teleoperation is likely acting as a capability bridge right now. It's a clever way to demonstrate what the robot will theoretically do in the future, while current hardware relies on remote human control to fill in the gaps where the AI currently falls short. But recognizing this gap, the gap between a highly controlled teleoperation demo and the long-term goal of an autonomous household companion, is absolutely crucial for keeping our expectations grounded. And this brings us to our final synthesis, the engineering reality check. We need to measure these trillion-dollar visions against the realities of fixed incomes. We really need to ground ourselves back in everyday reality and compare the financial feasibility of these two paths. Think about it. A Robovan operating as mass transit can split its immense engineering costs among 20 paying riders at a time. That makes economic sense for a city. But an Optimus robot, expecting households, especially families on fixed incomes, to shoulder the massive individual cost of a deeply complex personal robot just to end their chore list, that is a much harder financial pill to swallow. Combine that with Tesla's multi-year delays on past promises, like the original robotaxi, and an affordable, truly independent household robot remains very much a believe-it-when-I-see-it scenario. So I want to leave you with a direct choice to think about, based on all the engineering realities we've uncovered today. If you had to choose right now, would you trust a wheelless, no-override Robovan to navigate chaotic urban traffic and take you safely to work? Or would you rather have an Optimus robot operating in your kitchen, helping you with the dishes? And think about that software hurdle we just discussed. Does the idea of a teleoperated robot make you feel safer because there's a human failsafe? Or is having a stranger's eyes inside your kitchen the ultimate privacy nightmare? These are the real engineering and privacy hurdles of our automated future. Thanks for joining me on this explainer. Keep asking the hard questions and keep exploring.